continuing with the explanation of the IP address system, just reviewing about all the theories that the class came up with about how computers and devices get IP addresses. The first theory was that the factory gives an IP address to each device that it makes. And yes, that happens, but the address that the factory gives it is not exactly the IP address, it's a MAC address. A MAC address has nothing to do with the Macintosh, it's just an acronym for something that you don't have to memorize or write down. But the MAC address is an address that the computer uses when it's communicating through the internet, but it's only used for communicating in the local area network or the LAN. So, like for example, inside your house, the computers and devices will use the MAC address to talk inside your house. But the minute messages go outside your house, the minute that it wants to go to the internet, it's not going to use the MAC address anymore, because the MAC address is not a nice, neat geographical system like the ones you guys made in your groups. You guys made systems in your group where if you look at the beginning of the address, you can tell that that address is in a certain continent or country and city, and that's the way IP addresses are. MAC addresses aren't like that because the person who gives the MAC address is a factory. So it's like all the Samsung devices have MAC addresses that start with the same number, and all the Motorola phones have MAC addresses that start with the same number. So it's not geographically logical. So it's no good for trying to deliver a long distance message. The only thing it's good for is talking in a very small network, such as inside the house or inside EAC or inside a university campus. Any larger than that, you don't use the MAC address anymore. Okay? Okay, the second theory was that the computer picks one itself. Okay, at the very beginning of the internet, this was the method that was used. Actually, the computer doesn't really pick it himself. A technician who plans the addressing for a campus or a company, he would assign the addresses very carefully, and then he would take each of the addresses that he assigns and he would go up to the computer and he would type that address into the computer so that the computer would always use that address when it was turned on. So, and you know, any kind of mistake that the person made would cause a problem on the network, because he would end up putting two addresses on two different computers, and the computers could not correct the mistake by themselves. The person would have to figure out what was wrong and do that. Okay, so this was a method that was used a long time ago, and today it's pretty much not used anymore, because now there's like so many devices on the network that it would be too complicated for to make this work. And you know, as now with Wi-Fi, you have visitors on your network all the time. So how can you have a person assigning those IP addresses? You can. It's too busy, right? It's too big of a job. So that's why this is handled automatically by a computer, and people don't do this anymore. So the third idea was that when you subscribe to an internet service, then you get an internet address. And yes, that's true. Usually that address that you get is a address that changes each time. They're not obligated to give you the same address each time. So that's the problem with, like, let's say that you want to have some kind of server in your house, like a web server in your house, or a you know, like a printer that's going to be accessed from outside your house. If you don't have the same address all the time, it's hard for people to find that server. Okay, so in special cases like a business or a school like EAC that has their own web server, what happens is, in addition to paying for the internet service, the internet service provider companies such as Net or Telefonica, they promise to always give you the same address every time, and then you use that address that they always give you for your web server, for example. Okay? And the last case is assigned when you turn on or connect to the internet. This is actually the most used method now. It's like, especially for Wi-Fi, when you're a visitor on a Wi-Fi system, you are given your IP address by the hotspot or a computer that's behind the hotspot, and then um, you can use that hotspot for a while, and then after you turn off, then you give the address back, and you don't use it anymore. When you come back later, maybe you're going to get a different address. Okay, so now we're going to talk about DHCP. Here's an explanation, but I'm just going to go right to the skit that you guys performed in the class. So what happens with DHCP, and you guys don't have to memorize what DHCP stands for. DHCP is basically the automatic process which assigns IP addresses to computers as they turn on. So what happens? A computer turns on and it doesn't have an address, so it cannot talk specifically to someone. It can just what we call broadcast. It can yell at everybody and send its message to everybody on the local area network. So the computer turns on and he says, hey everybody, I don't know anybody's address, but is there anybody out there that can give me an IP address? Then one or two DHCP servers are going to respond to him, and both are going to say, hey, how about address 10005, or how about address 10110? So he gets two offers here. The computer chooses the first one he gets, and he says, hey, okay, 10005 is fine with me. And then the computer that suggested 10005 confirms. He says, okay, computer 10005, now you can use that address for 24 hours. Before the time expires, if you still want it, check back with me and I can renew the address if you need to. Okay? So that's kind of the way DHCP works. That's just, it's a pretty easy process if you think about it in the skit. Okay, now we're going to talk about network address translation, called NAT. And network address translation in your lives is going to be important in, I don't know, a few years, because someday we're going to be transitioning from IP version 4 to IP version 6. And another use of NAT is to translate IP version 4 addresses to IP version 6 addresses. Remember, they look totally different. IP version 4 addresses basically have 32 memory boxes in the address. Each box can be a 0 or 1. So basically it ranges from 0000 to 255.255.255.255. Okay, that's 4 billion different addresses. Now, the IP version 6, remember that it has up to like 3, and then it's got 38 zeros afterwards, a lot of addresses. So it's like, how can you put together the new IP version 6 network with the IP version 4 network? Well, you're going to have to do some kind of translation or mapping of all these addresses, and it's complicated, and maybe, because of that, we're going to see problems in the future. And as users of the internet, you kind of want to understand what's happening there. So, but today we use network address translation to translate between IP version 4 addresses to IP version 4 addresses. And you might say, what the heck does that mean? Why do you need to translate between an IP version 4 address and an IP version 4 address? Well, one of the things that they did to try to overcome the lack of IP addresses was they wanted to make it so that you can assign one IP address to a house or to a company or to a campus, and then even if you have 1,000 users or 10 users, 20 devices inside that house or campus, they can operate with one single IP address. And that makes IP version 4 much more capacious. It can handle a lot more people, because even though there's 1,000 people on that campus, they're still only using one address. So that really stretches the 4 billion addresses to much more than 4 billion devices. So here's an example of how that works. It's the same thing as when you have an apartment building that is on the street. It's got one address. It's got one street address. Now inside the apartment building, there's a bunch of families living there. Each family has an apartment number. Okay, so let's see how that works with IP version 4. Um, with IP version 4, think of this apartment building as your house, and your house just has an address to deliver mail there, and each device in your house has its own IP address. But like we just said, your house is only assigned one IP address. So how can each device in your house have an IP address to communicate? Well, what they do is they divide the IP addresses into private IP addresses and public IP addresses. Now, public IP addresses are real IP addresses that you can use to send an IP message across the world. And inside the house, you use our private IP addresses, which is like a fake IP address, which you use only to send messages between computers in your house or from the computer to the doorman or the router. So you have these fake IP addresses assigned to each of the devices in the house, and it uses this device just to communicate to the doorman, and the doorman is going to forward the message using his IP address to the outside world. How can you recognize these? And this is just a drawing of what's going on inside your house. So there's the doorman, which is actually the modem and the router, and it has the IP address assigned to it, the public real IP address, and then the router assigns each one of the devices in your house a fake IP address for them to communicate to the router. So how do we know when we have a private IP address or a local IP address or a fake IP address? Well, you look at the beginning of the number, and if you see that it starts with 192.168 or with a 10, then you know that you actually are using a fake IP address, which doesn't allow you to send messages directly to the outside world. You will send all your messages through a router or a doorman to the campus or the house or the hotspot that you're in. And so, you'll see that whenever you check your IP address for your iPhone or your computer, you're usually going to see that your IP address starts with 192.168 or with 10. And that just means that it's a fake IP address and you're inside a LAN where there's a router that's actually going to forward all your messages. 172 is not used so much, but that's also a possibility. Okay? And so examples of real public global IP addresses are here. So for example, Brazil's IP addresses start with 150, 139, 143, 177. They have all a bunch of little bands of addresses, and there's too numerous to mention here, but if you're interested, you can look up all the Brazilian IP addresses here on the site. Okay, and that was the end.